Container networking, moderated by Brendan. Brendan is a distinguished engineer at Microsoft, responsible for all of our container efforts, and he's a well-known figure in the open source Kubernetes community.
Is that working? All right, cool. Thank you, and thanks to the panel for coming here. Yeah, I can have the folks come up. We have Matt Klein from Lyft who's here. Purvi Desai, is that from Google and Google Container Engine? And Deepak Bansal from Microsoft is also here, so who's been emceeing, I guess. All right, so yeah, we'll have everybody take a seat. All right, I have my questions here on my phone. So the first question that I had for everybody was, I just introduced everybody, I guess, but who are you and what do you work on? So we'll go up and down the line there.
All right. Me, Purvi Desai. I manage Google GK networking and Google's GSLB, that's a global software load balancer, and some part of service mesh management from the LB point of view. Prior to that, I have been in the network and security infrastructure from 18 years. So,
cool. Can everybody hear in back? Is that loud enough in back?
Hello, on.
Maybe we'll bring the mic a little closer to everybody's face or turn it up.
Hey, I'm Matt. I'm a software engineer at Lyft, where I've been there for 3.5 years. I've spent the last 10 or 15 years working on operating systems, hypervisors, networking. My early career was mostly in virtualization and kind of low-level networking, but for the past about 6 years, I've worked on application networking. These days, I'm mostly known for an open source proxy called Envoy, which has become very popular.
Hi, I'm Deepak. I've been emceeing the whole day. I run Azure's SDN team, which includes Azure Virtual Network, Software Load Balancer, DDoS protection, and such services, including container networking. I've been in Azure for 10 years.
All right, cool, thanks. So the first question, this is really around, the whole panel is sort of around container, but I'm going to broaden it to sort of cloud native networking. And we're getting everybody mics. The first question I had was basically, what does cloud native networking mean to you? So we've seen a bunch about hardware and everything else like that. And then does it even exist? Like cloud native has sort of become kind of very buzzwordy, and I suspect we'll hate it as much as DevOps in a few years. But like, does the term exist as a real thing? And if it does, what does it mean to you?
oh, okay. Can you guys hear me? Okay. So it's a very tricky question, but let me give it a try. So as I understand from the cloud native, the whole trend started as developers should be able to run whatever they want to run, however they want to run, without worrying about where they are going to run this. And that means you can run in private cloud, public cloud, and virtual environment, and it should just work. As far as networking is concerned, whether that cloud native networking doesn't exist, that's the question, right?
Yeah, and what is it?
Yeah, what is it? I think I'm a bit biased, and I would say I do love Kubernetes networking as a model. And I think it started off with a very nice abstraction and having a plugin model whereby, hey, I could run it anywhere as long as I'm adhering by this specification, which is pretty straightforward and simple, and it works. Have we reached there? I think as far as connectivity is concerned, maybe so within the cluster. When it comes network services across different clusters, outside the cluster, I would say there is a lot of work that needs to be done. So when it comes to on-premise connectivity into cloud, even there, the work needs to be done. So.
I think for kind of the quote, cloud native networking for me is mostly thinking about what we want our devs to actually be working on. And the way that I look at it is that I think, we all love to talk about networking and all of the very sophisticated things that we're doing, but for most companies, infrastructure is essentially overhead, and most people don't actually care about it. If you talk to most companies, they really want to be focusing on writing actual business logic. So for me, the idea of cloud native is basically taking the network and just essentially making it go away, so that people don't even need to know how it works. And I think that's the idea of most, quote, cloud native technologies, whether that be databases or networking or something else. It's really just the idea that people should be able to take their application code, have it run, have it be able to talk to other services, store data, use caches, and have that be a complete abstraction.
Okay, can everyone hear me? Yeah. So I'll just add to that. Networking is really hard. Like when customers deal with networking for VMs, managing all the various rules, they get it wrong many, many times. And doing it for containers is even hard because the workload is so dynamic and a lot more containers to deal with. So there has to be an easier way to do networking for containers. And that's what I think cloud native networking aims to achieve, to make networking easier to set up, easier to manage, easier to diagnose, easier to use.
Cool. So I should say I wanted to make this a little bit interactive. So if you have questions that or follow-ups or things that people say that make you want to ask a follow-up question or something like that, please make sure you raise your hand or just stand up or go to one of the mics, and we can have follow-up questions or anything that's related to what the people are saying on the panel.
Actually, I have a follow-up.
All right, you have a follow-up. You have a question or a follow-up comment?
I have a comment here.
All right.
So when Matt mentioned that he would love developers not to worry about network, right? So in my first 8 years, I was just worrying about IP and network. Then the next 8 years, how the network can just disappear, right? How do we get the proxies or whatever we want in between, and somehow developers need not worry about where it is. As a matter of fact, not just developers, even the operators, in terms of, can I just not worry where my services are? Whether they are on premise, whether they are in the cloud, whether do I need to set up a VPN? Do I need to set up SSL VPN or some other VPN? And all of these questions, people want it to go away. Right? So I think that is something that we have not yet addressed. We have addressed the connectivity part, but not that.
All right, cool. Trying to decide if people getting up is people asking questions or just people getting up. Just getting up, I think. All right, so you mentioned that developers want to forget about all this stuff, and I think I sort of agree with you. Except for I think that there are aspects of networking that developers both care about and need to care about. And so I guess that leads to the follow-up question, which is, what is the top feature that developers do want from networking? So what is it that they don't want to forget?
Somebody else wants to.
We don't have to necessarily go in order either.
Yeah, so what I typically say about this is that I don't think we want application devs to not know about networking concepts. So for things like, what's a timeout? Like, how do you do retries? What does service discovery mean? Like, do you use a weighted load balancing policy or a hashing load balancing policy? These are things that typically have application implications. What I think the important distinction actually is do developers have to know how they're implemented? And I think that's actually key. I think what we've seen over the past 5, 6, 7, 8 years is, we've seen like this huge heterogeneous environment. People are using lots of different languages, lots of different libraries. People don't have observability. Maybe they have retries. Maybe they're broken. Like, it's a total mess. So I think, some of the platforms that are starting to evolve around technologies like Envoy or other systems like Envoy, the idea is to, encapsulate a bunch of that functionality so developers know that if they do a timeout or they want a particular type of load balancing, that will be there for them, but they don't have to know that how it's implemented, and they don't have to worry that it's not consistently implemented.
Yeah, I'll say that while for the most part we want developers to forget about networking, but the rest of the ecosystem will not let them forget about networking. Your security guys, right? When things go wrong, your DevOps, they want to look at what traffic is flowing where and what not. right? So if you were to leave purely up to developers, they will not care about networking, and that's fine. But the moment you put it in production, there are facts of operation in production that require the overall ecosystem to care about networking, and hence we need to provide those mechanisms such that the service can be operable in a production environment and can be secured in a production environment, yet without putting it in the face of the developers.
So I think you guys covered quite a bit of it. The way we are hearing, not just from developers or even from operators, a couple of things are visibility. What went wrong? You just tell me what went wrong. Like, network is such a nebulous thing for me. I need to understand what went wrong. That's one. Second is it's kind of a lofty thing to say. Everybody says self-driving network. But really what they want is, I should not be worrying about how many prefixes can I have for this and that. And this is more of an operator thing, not necessarily developer, where how should I carve out my application space? Right? Can you just take care of it? That I think there are two pieces.
Cool. So one of the interesting revelations for me when I started into cloud networking and thinking about cloud networking was that in the cloud, the L2 basically doesn't exist, right? Basically, routing as a concept doesn't exist. Like, there is routing, but it's all happening encapsulated by the cloud provider, right? And so suddenly lots of things that were built, so for example, I've had customers say, why is your NIC in promiscuous mode? Like, aren't you sniffing packets on the network? And you have to explain to them that, like, literally there are no packets on the network. What else do you think changes? Like, we're so used to building on this thing where there was physical wires and there is things actually transiting the physical wires, and in cloud, it's gone away, right? What else like that is there that has sort of fundamentally changed when you think about in cloud networking?
I'll say subnets as a notion, right? In the past, you would have one VLAN or one subnet for, and maybe this is same as layer 2 has vanished, but I'm referring more from the perspective of ACLs and isolation, right? Doing isolation based on IP addresses and subnets is becoming arcane and more arcane, and things like
But people still do it.
People still do it.
Very frustrating.
Right. With security groups, things should become easier, but still, I think maybe there is an opportunity for even a higher abstraction to provide security for an application where the application author doesn't even need to provide even security group or specification, and the system automatically detects what the connectivity is needed by the application and automatically secures it without the developer having to worry about it.
Yeah, there's probably two things. I think the first thing is that from a cloud native perspective, I think what you don't see, or you do see there versus kind of old style networking, is cloud native is inherently elastic. So we're doing auto scaling, we're doing functions, things are coming and going, and that type of elastic scaling, it I think creates an order of magnitude larger set of problems around how do you think about problems, how do you do load balancing, how do you do service discovery. And you'll see that from people who have done security a particular way. So one thing that comes to mind, which is my personal favorite, is you'll deal with third-party companies who still do security based on IP address or something like that. And if you're running entirely in a cloud where all of your IPs are elastic, like that, it just doesn't work. So I think that that's one part where we're essentially taking certain things that people did before around how they do security, how they do ACLs, and those things just don't actually apply. And then I think that from a cloud perspective, The other thing is people are inherently moving more towards layer 7. And I think you see that through newer protocols, whether those be gRPC or something else, where developers, they don't necessarily care, again, that IP packets flow a particular way. Like they want messages. It might be Redis, it might be gRPC, it might be PubSub. So developers, they're thinking at that higher layer, and once you expose to a developer that, oh, you don't need to worry about this L3, L4 stuff, why would you do ACL on an IP basis when you can do ACL on a path basis? And I think that's the main key, is that developers, once you give them layer 7 that you can do when you're operating at the application layer, everything that came before, it seems very not relevant.
I'll add one more thing, which is around naming and discovery, right? DNS protocol widely used, but more and more in the containerized world, people have better way of doing naming and name resolution, and discovery is also something that I think is fundamental to the containerized workloads, and we need better mechanisms, more standardized ways to do discovery and to do naming.
Anything else? No?
I think this guy's covered very interesting things on what is coming in when things are going away. I think all this coming in is all these high-level abstractions. And I think the control part, which is going away, which is hardware, which of course is covered. But I think the other thing is that people are kind of lost is diagnostics, I think. They just do not know where exactly can I begin. Because earlier they were able to do this themselves. Now, the moment you come to cloud native, that is one. But then what you're getting in return is all these high-level abstractions, which are much more powerful. So.
All right. So this is sort of related to that, and a follow-on. I still encounter many customers out in the field who literally are not allowed to provision a cloud network. Right? The cloud networking has to go through a ticket to the networking team that provisions the cloud network for them. What tools are missing that make that network administrator or make that networking team feel like that's an essential part of how they need to operate, right? I don't think it's just sort of like, job protection. I think we lack, and this gets to the discoverability and the problems that happen. Mm-hmm. Like what do we need to build as a cloud networking to enable that networking team to feel comfortable about handing us the keys to the developer?
Basically, networking team should be able to create guardrails.
Right.
And then each application developer should be able to then manipulate themselves.
Right.
And I think as long as network operators are able to audit this, that whatever guardrails they have set up, first of all, they should be able to set up. Once they have set it up, then they should be able to monitor this and audit it. And they should be able to, I guess, at some point, even put right kind of policies around what exactly, how much bandwidth, how much quota, what all can they use. I think these are all the high-level policies. If they can install and audit, then I believe they would be a lot more comfortable in saying, go ahead and now create whatever you want to create in your free will. And
do we have a sense of what those policies will be?
Exactly.
What do you think? What do you think those policies would be? Putting you on the spot slightly, or anyone else on the panel.
So this area is very near and dear to me, just because I think it doesn't only apply to networking. I think in the cloud native space or in the DevOps space, we like to pat ourselves on the back and say that all of these tools are very easy to use, and they're not. I mean, they're incredibly hard to use still. And I think the biggest problem is, right now, if you look at Kubernetes, if you look at something like Envoy, if you look at all the other tools, you're left with thousands and thousands of lines of YAML, right? And people build different higher layer programming languages, and there's an entire industry now of cloud native programming and all types of things. But I am a firm believer that as an industry, we have to invest in actual user interfaces that allow people to configure these systems, and that's where you put in these types of guardrails. So from a policy perspective, I can't I can't go on the spot and say what are the policies. This is like a giant topic. But I think what's more important is that from an organizational perspective, you want a user interface. So you can imagine like the existing cloud consoles, whether that be Amazon's console or Google's console or Azure's console. And you want to expand that out to L7, and ultimately you want people to be able to configure things, allow different policy parameters, and then specify on a team-by-team basis, here's some templates from a user interface perspective. So you can go and you can fork off your own service in this template, and here are the few things that you can actually pick and choose, and here's some UI guardrails with which you can actually do that. And none of that exists currently. Like it's people will have IAM policies or different things, but it's still a hugely confusing mess. So I really think that the next generation, over the next couple of years, like a lot of the fundamental technologies exist, but how we configure them, I think that's actually the hard part.
I have a slightly different perspective here. I think the reason network admins have so much sway over provisioning of the network is because of security. Network is one of the key aspects of security that any organization leverages. Until we remove that, it will always be that developers will have to go through a network admin to ensure security of their application. Now we can argue that maybe, hey, applications secure themselves through TLS and whatnot, but that's similar to saying that, hey, I'll remove the lock from the front of my house and I'll secure each and every valuable that I have in my house. I don't think that's going to happen anytime soon. And that's why I think rather than saying that, hey, let's get the network admin completely out of the picture and let's build this technology that does not need network admin, it's better if we build technologies that make it easier for network admin to do their job, that makes it easier for them to be able to review what the security posture of a given application, a containerized application is, and be able to approve it or change it or modify it more quickly.
Yeah, I mean, I think that's true, though. I think it goes beyond security, just because. So for a concrete example, if I look at Lyft, I mean, right now at Lyft we have a very complicated networking deployment based on Envoy. It's this fancy service mesh thing, which ultimately boils down to thousands and thousands of lines of YAML, and we have lots of tests and guards and all of these things, but without people that still understand the system, even beyond a basic security perspective, it's too easy for someone to come in and take a route for /foo and suddenly start sending it to the bar service, and now Lyft is down, right? So like it's all of the policies. Like it's not just security. It's routing. It's overall system safety in terms of rate limiting. It's each of these components. I think we're actually agreeing that it's not that you want to take the network admins out, but you want them to almost define the parameters, I think, by which people can actually work.
And to add to
Can I
this,
just jump in there for a second?
Yeah, real question.
Very interesting conversation. It's not a question, I just want to make a couple of comments. What I heard, I'm a networking dude. What I heard from this is we want to get the developers to not really be concerned about the network underneath. We want to extract it away. But the problem with that model is that it's the network developers that are obviously putting the traffic out there in the first place. So, for example, if every network developer was to put out their application with specified best possible quality of service, you've got nothing but an Ethernet broadband network, right? I mean, it's worth nothing. So the application developers have to understand the implications of what they are doing with their applications at the network level. So if we're saying we've got those developers that really don't need to know, you need to find new developers, call them junior developers, and get some real developers in. That's my first comment. The second comment is that you talk about network administrators. It's not what a network administrator may be the guy that configures the switches and so on, but he's doing that because he's conforming to whatever the security ops team for the organization has specified what's required. So when we're talking about how would we fix this problem, it has to be done with policy, as you've said, but it's a security policy. So if you put yourself in the mindset of an enterprise customer, The enterprise customers concerned are really about, the security, the enforcement of the security, the auditing of the security, the compliance checking, and so on. But the other thing you have to consider is that from an enterprise customer's perspective, they've been guarding the crown jewels of their business for years. They don't trust you, right? They don't know who works for your organization. They don't know that the guy that's looking at those virtual machines, whether that's running in your organization, what that means to them. They didn't pass any of the security checks of an enterprise organization. So you have to think to yourself, okay, well, this is the problem. This is the trust problem I have in dealing with an enterprise customer. How do I solve that? It's not how do I make it easy for a customer to consume my services that's going to break their security model.
Absolutely. I think, so I think you raised a very interesting point, which is one thing that went away, the control, which was the security. Like one of the things that I had earlier, a machine in my hand, I knew I had locked it. I knew who was connecting the ports. Now that thing is going away. So there is definitely a trust model that needs to be specified in the policy, which can be verified and it can be audited, right? So that definitely goes hand in hand. Other thing, although I'm seeing in enterprises, at least in my previous life, which I have seen, is the concept of perimeter itself is kind of gone, right? In a sense that the clients could be anywhere, the services could be anywhere, and they should really be able to connect without having to worry about, do I have all kinds of firewalls in between just based on IP? And then it goes to like slightly higher level, like application-based securities, and as Matt was pointing out, which was mesh-based securities and things like that. So I think there are two trends that are going on. One is, can I have the visibility that I need and security policies plus network services policies, load balancers, and naming as a guardrail? And the second one is, if I have trust that at the end of the day, I am not so much concerned by the perimeter, my design and architecture is such that it's not really encumbered by the perimeter, then itself kind of stands the test. Right?
So I agree that So I agree the perimeter model is the one that we need to get away from the perimeter model. But just because we've gotten away from the perimeter model, one way is to say, get rid of the perimeter. We'll do it with different tools. But the other way to say is that, in fact, the perimeter keeps shrinking in. So the perimeter now becomes the container or the VM. So each one of those containers or each one of those VMs has to have the same level of protection around it that you used to put around the enterprise perimeter.
Yes, absolutely.
Yeah, along those lines, I think a big trend is towards disaggregated firewalls and management of disaggregated firewalls. I think, of course, doing it at an IP address level or subnet level is not the right way to do it, and we need higher level abstraction. But I think we need mechanism to provide disaggregated firewalls that can be easily managed and easily rationalized.
So I'm going to take it in a slightly different direction, if that's all right. I mean, it's related, actually, quite related. Unless did you have something?
No. Go.
All right, cool. So Matt mentioned a number of times the piles of YAML, and this is definitely something that I think about a lot as well. I think actually you're probably in a good state if you're configuring your networking with YAML. Like my first networking configuration, I think, was SNMP. And so networking, I think, tends to be sort of in an area of arcane configurations, and then eventually it's JSON and YAML and that sort of thing. But what is the right end state? Right? Like, what are we supposed to be shooting for if we have to configure and program these things and set policy and all that sort of thing? Like, what is the right goal?
So there's nothing wrong with YAML or JSON per se. Like, it's a structured language. You can have a schema. You can have something like protobufs, which can be translated to YAML or JSON. So like from that perspective, I don't really have a problem there. I think actually what's more interesting is what are the layers by which people use this. So from an Envoy perspective or from a service mesh perspective, what we're seeing at this point is, although you can write Envoy configurations by hand, what everyone is doing from a production standpoint at this point is they're all making a computer program that takes in other inputs and they're spitting out some giant configuration. So I actually think what's more interesting is not that there's an end state by which we're going to invent some new programming language or some new YAML variant that's going to, kind of take over from YAML or JSON. I think it's to appreciate the fact that we are going to have different layers of abstraction, and something like Envoy or other systems or Kubernetes, they might continue to speak YAML forever, but we're going to build increasingly opinionated systems on top that eventually get translated down. And in the future, if you have something like, functional or lambdas or serverless or something like that, it might go from a UI console to some other translation system, which eventually spits out some API, which eventually goes down to YAML. So I don't think it's about finding a be-all and end-all, because these systems just are inherently complicated. I think it's about building the right opinionated abstraction so that when it gets to the average end user, I think it can basically work for them. And sorry, I did want to just respond really quickly to your comment about that developers don't understand things like low-level networking. And between you and I, look, I totally agree that it would be great if every developer today, even ones coming out of college, or everyone had a good understanding of low-level networking, computers, operating systems, whatever. The boots on the ground reality is that is just not the way that it is. So for people that are running infrastructure at internet companies, you're trying to have a balancing act of building an infrastructure, that people who expect a very high level of abstraction that they can use, and you're trying to meet somewhere in the middle. So trying to, have them understand retries and timeouts and circuit breaking and those types of things, like those will continue to be the case, but asking them to understand at a low level how flow control works and how a TCP works, sorry, it's just not going to happen. So it's kind of finding that middle ground and building those different levels of abstraction.
Yeah, I'll add the future state that we want to get to, right? I'll throw two things here, right? One is this notion of intent-based networking, right? It's a buzzword. I don't know how real it is, but it would be nice to have a language that's easier than the current language, even with YAML, of specifying network policies, right? And the second thing I'll throw out there is this notion of network should learn, right? One of the ideas that I've come across that I like a lot is observe what traffic is flowing on the network and then auto-generate the rules to block everything else, so that someone doesn't need to manually put the rules. The rules are auto-generated, and then any anomaly gets automatically blocked because everything is automated.
Cool. Anything else? All right. So the next question that I have is, in the development of cloud native networking, Kubernetes in particular, that I'm particularly familiar with, we've seen what I would call significant abuse of kernel networking features. IP tables being the primary culprit here, but we moved on to IPv-LAN and BPF in some cases. And do you think that in this move to more application-oriented networking, to more developer-centric networking, there are low-level operating system features that we need to build that are more aligned to the fact that they're going to be used for this kind of application networking? Like, they were built around very certain classes where machines were the thing, and now we have all these containers running on the machines, and we're treating them individually, but the networking stack doesn't really know about them. Is there stuff in the operating system that we need to do to enable those use cases? Or even in the networking hardware, for that matter?
Yes.
Yes. Okay, what is it? Sorry, it's the wrong question.
Do you want to go?
Do you want to put Envoy?
Well,
In the
so, so for people that don't know, so it's this whole service mesh architecture is basically that you take a sidecar proxy. So it's not a library. So you have a separate process, you're running it next to your application, and people's primary complaint or their first reaction about this architecture is it must be slow. I mean, you're running this other process, it's going to add a bunch of latency per hop. what's been really intriguing for me to see over the last year or 2 years, and it's increasing now very rapidly, is we have a bunch of kernel developers who primarily work on BPF, and they are doing some incredible work right now to basically effectively run Envoy, but run it in the kernel. And what they're doing is, they're doing a bunch of things around trust and like various other things, but the idea is that you can make Envoy as fast as if it were a library within the process. So you can get rid of all the context switches, you can optimize how the packets pass back and forth, and you can effectively make it free from a library versus a process perspective. So, I do think that from the kernel perspective, I think that when you look at a service mesh or an application-based mesh architecture, a lot of the stuff that you were talking about IP tables and BPF and all those things, like those just go away. They're just not needed because Envoy handles all of that routing up at the application layer. But I think where a lot of the interesting stuff will end up being done is both to make something like Envoy run faster, and also for certain security scenarios, particularly around DDoS and certain things where you don't even want to go up to Envoy, you'd like to pair security policies at the kernel, probably using BPF with something like Envoy. So I think you'll continue to see this dual rollout. But at the same time, it takes so long for kernel features to actually roll out, many years to get them to a particular enterprise, that being able to do as much as possible up in user space is pretty compelling.
Cool. Anything else?
I think when we mention Envoy, what are we saying? We are saying that service discovery, load balancing, some of the security policies, all of it, we want it in a way that it is in the kernel, right? And that is what everybody else is trying to do, eBPF and all. The other model, which is I think supported by eBPF, can I offload my TLS, right? So similarly, when we come to gRPC, for example, in gRPC load balancers, we are saying, can we do look aside, right? And in the look aside, what are we looking at? It's the all the same functions. Security, auth policies, user policy, service account policies, so, service discovery. All of it, if it can be taken up in the kernel, some of it, if not all, that would be a good win, because then developers don't have to worry about setting it up, either sidecar or in their own application.
I'll add, why stop at the kernel, right? Nick talked about running stuff on the TORs. Can we run Envoy on TORs? I don't know.
Right.
Maybe that's
To take that
smart.
slightly further. So another topic of discussion that has come up recently has been socket activation or paused containers, right? So like, I've got an inbound networking flow. I know what's supposed to handle it, but it's not running yet.
Right.
Traditionally, that has been something that has been handled at the application layer. Like you have to have some application sitting there that terminates the connection
Right.
and then redirects at the right time. Is that the sort of functionality that we should expect or want to see in either the cloud networking fabric or the actual physical hardware fabric, where I can effectively pause a flow,
I mean,
wait for something to come up and then finish the flow?
That functionality is already built into Envoy, and we have people
Sure.
who are doing it, from the serverless networking perspective. So we have people who are taking requests, they're pausing them, talking to some backend management server, and then once the management server says that a target is up, it'll keep going.
I mean, it's been happening in the application layer for a long,
Yeah.
long time. I think the question is, as we push towards cloud-native networking, container-oriented networking, does this become a fundamental characteristic of what it means to be networking? Right?
I think so.
I
Yes.
think it would be very interesting. Some of the things that I was talking about in the beginning, that network services, network security services like antivirus, DLP, XYZ, right? The people want it in their system. But right now, in order to integrate that into their ecosystem, they have to really do sing a song and dance to get there. If certain primitives like that, like pause, in order for certain events to happen, if they are there, I think it opens up an opportunity
Yeah.
for all those network services, security services really they are, to
Yeah,
operate.
you can also imagine, pause this flow, I don't know where it came from, I want to
Right.
do some DPI,
Yeah, do some DPI, come back.
come back, yeah.
So, and going back to my original point, that when we were saying guardrails, we're not saying network admin should not worry, the developer should not worry. Developers should be able to say exactly what services are required for their services. Like network services are required, like DLP or antivirus. But it's just that it should be something straightforward, which does not need like every small change needs to go through a change request and 1 week of wait.
Cool. So one other thing that I've run into personally is some of the challenges when it comes to bridging cloud native or container networking and on-premise networking. So we had great problems where there's IP addresses in a Kubernetes cluster and they're virtualized and all the routing is beautiful inside the Kubernetes cluster, and then it sends packets across a VPN to on-prem, and they get there, and the VPN has no freaking clue how to route it back, right? And so I guess I'd be curious to know. Unfortunately, we've solved a bunch of those problems with the Azure CNI work and things like that. But I'm curious to know what are the problems that you've seen as you've seen cloud networking intersect with on-premise networking, and what do we need to do there to improve things?
Yes. I think what you raised right now is a key. That's a basic connectivity. Like, how do we get the connectivity going? Of course, the same story, BGP, reflector. Can we solve all the problem? And that is one way of doing and solving the issue. Second is network services. Like, how do I get between the two clusters, the pod-to-pod connectivity? I think this is something that we are still really looking at. Some people would say, oh, let's just use ECM, like mesh. Right? And let's get this out. You have a service discovery right next to the application, and then you can connect. So that is one approach. But I think we are still looking at options, if you ask me. This is still something which is not solved completely. From a network services point of view, how do we get multi-cluster, either on-premise or within the same infrastructure? Right? We slowly and gradually, we're starting with L7 load balancers, but then it's still something which is evolving.
Yeah, I mean, from my perspective, and I'm a total broken record here, is I think layer 7 is the solution to almost every problem. And when we did Envoy at Lyft, and how I see other people rolling something like Envoy out, is my recommendation to people is, if you're thinking about IP tables, you've already gone wrong. Like, if you're talking about BGP, like, stop, right? I mean, it's just, all of these technologies, I understand that most of the people in this room are very passionate about them. No one else cares. So it's, and when you go to I'd say the average developer at the average company, you can explain to them L3 and L4 and up networking, and they kind of get it. And then you can explain to them, oh, you put a gateway here, and you can do a forward proxy, and then it'll proxy across your VPN link, and then you can proxy here. And that makes sense to most people, and people have success with that. So my recommendation, honestly, for most people who are deploying in these split architectures is keep it as simple as possible. Set up basic gateways, do L7 forward proxy, do basic tunneling, but do it all at that layer. And in my experience, people end up having far fewer operational problems.
So Matt,
just
go ahead.
because I've run into problems with this recently, what about things like SSL?
Sorry, what's that?
What about SSL?
What about it?
If you're putting a gateway there, SSL becomes, and you want to stay in L7, SSL becomes very difficult.
Sure.
Because you have to either terminate and reconnect, or you have to, crack it and lie, or there's.
I mean, there are options between those two, and this has come up a lot recently. So, for example, in Envoy, we can do routing based on SNI. So, there are things in plain text or at L4 or L7 where we can figure out the original tent, and then we can package it basically into some type of tunneling system, and then decapsulate it, and then send it on its way. But I completely agree that it is a harder, more open issue. But again, a lot of that depends on the security requirements of the particular deployment. I personally tend to favor simplicity of operation over security that makes security people very upset, but I think that you can compromise in the middle. But every enterprise is different.
So do you end up reinventing all the mechanisms that are developed in layer 3 and layer 4 in layer 7? For example, you just talked about encapsulation, right?
Sure.
That's a well understood concept in layer 3, layer 4, built in.
It's well understood, but it's
service
almost always broken.
insertion.
I mean, it's
I think once you add it to layer 7, you'll find the same challenges that now have to decide about where to send it to, and if that device is down,
Sure.
I need to fail over to another one.
Yeah.
So I'm just like, there are some capabilities that exist in layer 3 and layer 4 for a reason, while application developer doesn't want to think about it, but from an operations, from a overall system architecture perspective, those mechanisms for service insertion, for security groups exist for a reason, and either we say, hey, they are not needed, then you should stop reinventing encapsulation and service insertion mechanisms in layer 7, or if you buy into that they are needed, then let's just use layer 3 and layer 4 for that and stop fooling ourselves that, hey, we'll reinvent those mechanisms in layer 7.
Can I interject for a second? Because I'm very interested in this as well. And I got 3 minutes, so, you know. Because I'm actually asking a different question, which is to say, do you think encryption in L7 is necessary? Right, because we're talking a lot about SSL and certificates and all that sort of thing. I might actually make the argument that things like Envoy and the fact that there's no L2 at some level says actually encryption is not something that the application developer should think about. Like that it is a decoupled.
Agree.
And so my question was actually perhaps incorrect, because your answer should have been there's just Envoy on both sides and the application developer didn't think about it.
Okay, I mean that probably was my answer, but I mean from an operational perspective, you're right. I mean, because what we see is that in order to get full benefit from the mesh, like to get observability, to get logging, tracing, all of the metrics, Envoy has to decrypt. So from that perspective, what we see in most deployments is people are doing point-to-point TLS, but in non-traditional enterprise environments, where maybe there's some old requirement that some traffic transits and it's encrypted. In more modern companies, that's just not a particular issue. I did want to quickly respond, which is that I completely agree that, I mean, from an industry perspective, we endlessly reinvent stuff, right? And that's bad. At the same time, particularly from the cloud product perspective, there have been historically a lot of operational issues with trying to get a bunch of the tunneling and like the more arcane cases actually working. So I think part of what has happened from the L7 perspective, it's been done somewhat out of necessity. It's like the cloud providers are not getting it done at that layer. It's too hard to use, or it's broken or something like that, and we can just fix it up at L7, and that's been pretty effective.
My take on this is a bit different. Maybe I'm just greedy, but I would like to ride both horses. And here is why. The fact that developers should not worry about network, I think that is, they do need to know what network services they need, but they should not worry about how VPN tunnel is set up, how keys are being distributed for SSL. This problem needs to be decoupled, and in both scenarios, right? Now, the use cases, I feel they exist in both in both the solutions. I can envision like stock ticker or some kind of applications where having a very high throughput, very low latency is like must, and I'm not going to take two proxies in between, right? So the question for us, I think, as a technical community, is to figure out whether can we have something where setting up a VPN tunnel is not an arduous function. Whatever SDN could not achieve in Act 1, as somebody was saying, could we do it as a part of CNI? Can we specify a way of setting up tunnels and the connections between different service providers and all